Okay. So this is what we know about go back N so far. So the go back N protocol simplifies the process of the receiver in the sense we have seen that while the sender window, right, is of size N, right? Sequence number space 2 to the power M, and the sender window must be less than 2 to the power M, at least one less. And let me open this as well. We saw one slide. Can you guys see the slide?
Yes, sir.
Yes, sir.
Okay, this is a figure I wanted to show. Okay, if you remember this slide, there were two cases of sender window of size less than 2 to the power M and of size equal to 2 to the power M. And the second case, we saw that exactly. The first packet is resent at the sender, but the receiver mistakenly thinks of it as the fourth packet, as packet number 4, right, 0 or fifth packet, as a new packet.
স্যার আপনি কি কোনো ডিফারেন্ট স্লাইডে গিয়েছেন স্যার? একটা
হ্যাঁ কথা আছে, আমি আবার দেখি, সরি। ওকে, আবার দেখি ওই লাস্টের এই যে রিকল। ওকে, এই স্লাইডটা মনে আছে?
জি স্যার।
ওকে, গুড। এই যে এখানে দেখেছিলাম যে two cases, if the send window is equal to 2 to the power M versus 1 less than 2 to the power M. এই যে an extreme scenario where all packets are received but all acknowledgements are lost. In this scenario, it is possible that if the first packet is resent with packet number 0, in this scenario, it's correctly the receiver knows that this is an old packet which is received, it's a duplicate packet, it discards and resends the ACK again. Same scenario in the case where if the receive window is allowed to, send window is allowed to be one more, right, equal to 2 to the power M, here M is 2. So sequence number space is 0, 2, 3. So in this case, packet 0 is resent, but the receiver window advances to accept 0, which is essentially wrapped around new 0, right? But it accepts the old 0 as a new 0. So essentially, receiver erroneously accepts a duplicate packet as a new packet and delivered as new data. So from here we saw that the send window needs to be at least 1 less than 2 to the power M. এখন detail আবার যাচ্ছি না, but just to recall that we did this because we need this knowledge today. Okay. Let's go back to today's lecture. Start today's lecture. Okay, so the go back N protocol, and we saw that the receive window remains 1. এখানেও just to recall, ওই যে receiver acknowledgement কি দেখায়? Receiver sends ACK number N. What does that mean? Again? Anyone? When the receiver says acknowledgement 5, ACK number is 5. What does that mean? Which packets has the receiver received?
So receiver has received up to packet 4.
Exactly, right? Which is exactly his way of saying he has received up to all packets up to 4. And receiver has a window size of 1, right? Which is exactly the next packet he is expecting. So this simplifies the job process at the receiver, the memory requirements at the receiver as well. It keeps track of only one variable, and it does not buffer any out of order future packets, which are discarded. So if it receives, let's say, packet 6 and 7, it will discard. Because if packet 5 is not acknowledged, if the acknowledgement of packet 5 does not reach the sender receiver knows will send packet 5 onwards again. Will send 5, 6, 7, anything after 5 again. So there is no need for the receiver to buffer packet 6 and 7. So obviously this suggests an improvement. So this is inefficient or can be improved if the underlying network protocol loses underlying network loses a lot of packets. So each time a single packet is lost or corrupted, sender resends all outstanding packets, even though some of the future packets may have arrived. So the next protocol improves on this. So the next one is called the selective repeat. So instead of going back N and repeating everything n steps backwards, you only resend which have been lost. So in this case, send window must be like maybe like this. So to the left is packets already acknowledged, right? So SF as before is the first outstanding packet, outstanding, not yet acknowledged. SN is the next one that may be sent if the application layer passes down a message. Up to 7, and then this is your window size. Your window cannot advance. So sequence number 8 cannot be used unless 0 is acknowledged. Everyone, as before, all same as before. Now, here the difference is, previous case, go back and 0 to 3 would have been blue, saying outstanding and not acknowledged, right? If this is the last one to be acknowledged. Sorry, first outstanding packet, right? In this case, you may have some gray within the blue, meaning some in-between packets may have been acknowledged. So packets that are acknowledged out of order. Because in selective repeat, receiver will, so 0 has not been received. But if 2 is received, in selective repeat, the receiver will store 2, will buffer 2. Okay? So this is the only difference. And once again, yes. তো ওইটাই হচ্ছে exactly in go back and normally করবে না. Now today we are studying an extension of that algorithm. So in the extension or improvement is out of order buffer করে acknowledge করবে. So that is today's extension. Exactly. So now we allow this, and this protocol allowing this is helpful in scenarios where lots of packets are lost. So in that case, if some future are received, it's better to store them instead of asking for it to be resent. So which protocol you will use is a trade-off between which is more expensive in your system, processor and memory or network bandwidth. So in this case, if you're storing, you're using more memory, you're using more bandwidth, more processor at the receiver. In the other case, where you're not storing at the receiver, you're asking for everything to be resent. You're using more network bandwidth, but less memory and less processor at the receiver. So the decision depends on which is more important to you, which is more valuable. Okay. Okay, guys, I need a minute, okay? Let's think about it. Guys, I will need a 15-minute break actually. Okay, can we restart at 1 o'clock? Okay. Okay, everyone. It's kind of an important issue. Everyone, can you hear me?
Okay.
Okay.
Yes, sir.
Yes,
Okay.
Nice. All right, guys, I'm back. Sorry about that. You guys there? Can we continue? Anyone? Hello? হ্যাঁ, বাকি সবাই ফেরত এসছো? ওকে, কোথায় ছিলাম আমরা? এখানে। এই যে, so এখানে we were seeing that the difference to go back n is the addition is, এই যে we see that go back n receiver is simple, and because it's simple, it does not buffer out of order packets, and the system takes care of it in the sense that receiver resends everything that acknowledgement number onwards. So each time a single packet is lost or corrupted, sender resends all outstanding packets, even though some of the future ones may have arrived safely. So previously we missed this slide. So once again, let's look at the sender window. So this is the first outstanding packet, right? To the left, the packets have arrived at the receiver. Receiver has acknowledged them, and the acknowledgements have arrived at the sender. So the sender window has slid forward, and this is the first outstanding packet. This one would be the next one to send, right? So if the application layer passes down a message to the transport layer, this would be the sequence number given to the next outstanding. So the next packet to be sent out. And the window ends here. So more than this cannot be sent unless the first packet has been acknowledged. Okay? Once again, so now the difference here, the extension here is receiver is allowed to acknowledge. So in the previous case, all three blocks would have been blue, right? From here to here are packets that are in transit, in flight. So in this case, we allow that receiver may have acknowledged in between as well. So this one is gray, which is acknowledged out of order. Now, suppose SF, this packet is acknowledged. What will happen to the send window? Anyone? How many steps will it slide forward? Anyone? Anyone? Khadija, can you try? Persona Marzan? Very straightforward. Right? What I'm saying is, suppose this packet has now been acknowledged, acknowledged has been received. So what will happen to the sender window? Previous case, what would happen in go back n? Bolo? Now, as I'm saying, this SF is acknowledged. The first outstanding packet has now been acknowledged in this case. So now what will happen? Exactly. Right. So it will slide forward. It will slide forward 2 steps in this case. Right. This will be the right. So this will then be the first unacknowledged packet. Good. Good. Okay. Let's look at the receive window. So previous case, receive window was size 1, right? Which was just RN, right? Just the next packet to receive. Now in this case, receiver there is allowed to receive future packets up to certain amount. So AJ, this packet has been acknowledged. So in this case, the next packet is packet received out of order and acknowledged. And in this case, the acknowledgement has been received at the sender. If this is packet 0, packet 1, packet 2, packet 3, the receiver, packet 3 is also received, which means acknowledgement 3 has also been sent. Now here, this is white, means this acknowledged meant has not been received at the sender. So this is the difference. This is the improvement. So logical channel, once again, this is the same as before, right? Packets flow in one direction, acknowledgement flow in the other direction. So this is the detail of the sender window. Sorry, the previous iteration I had skipped over somehow the previous slide. So we see this, right? It's possible that in between packets have been acknowledged. So outstanding packets with some acknowledged. Go back and the caption here read exactly outstanding and unacknowledged. Here it's possible that some in-betweens have been acknowledged. Receiver, then this is the next receive into next packet expected. But he allows packets, some future packets up to some amount that can be received and stored for later delivery. So shaded boxes are those are already received and acknowledged. And beyond this, it cannot be received. So up to certain amount, future you allow to be received. So now if packet 3 is received, receiver window will again slide forward 2 steps. Right? Because 3 and 4 is then, this would then be the last unacknowledged, last not received packet number. Take a moment to go through. This protocol is called the selective repeat protocol. So once again, I will not ask you details about the selective repeat protocol, but understanding selective repeat will enhance your understanding of go back end. That is the reason we're doing this. এটাই তো হ্যাঁ রাইট সো এখানে হচ্ছে the receive transport layer would store them. Now remember, you cannot deliver the packets to the receive application layer out of order. This would be once again, right, WhatsApp messages if you're chatting with a friend, right? If messages arrive at your friend out of order, it will not make sense, right? If your words in your sentence arrive out of order, it will not make sense. So the receiving transport layer would buffer them. Once 3 is received, it will deliver to the application layer first 3, then 4. It will deliver in order. But in go back end, it would have deleted, discarded, or not stored any out of order receptions, right? Any out of order received packets. So in this case, we are allowing them to store out of order, and then once the remaining come, when the gaps are filled up, only then it will be delivered to the application layer, to the receiver application layer. But you will not ask the the transmission channel to resend. Okay. So next, so go back and we saw used one timer for the transmitter, used one timer for the last outstanding packet, because if this was not received correctly, everything from here on end had to be repeated. Now, since we allow individual packets to be acknowledged, we need a timer for each outstanding packet. And when the timer expires, only that package is resent. So this complicates the processor requirement, memory requirement at the 2 ends, right? But reduces bandwidth because you're not repeating sending. Next, in selective repeat, we saw then go back end acknowledgement number defined said that every packet up to that was received. In selective repeat, acknowledgement number informs only the sequence number of the particular packet received. So here you cannot have cumulative acknowledgement. So let's do this problem. So suppose a sender has sent 6 packets with sequence numbers 0, 1, 2, 3, 4, and 5. Sender has received an acknowledgement with act number 3. Now, if this system is using go back end protocol, what would be the interpretation? Which packets have been received? Anyone? What does an act number 3 imply? Which packets have been received correctly at the receiver? Which packet numbers? Exactly. And if this is selective repeat, it means exactly only 3 has been received. Right? Is everyone with me? So if it's using go back end, it means that packet 0, 1, and 2 have been received uncorrupted, and the receiver is expecting packets. If the system is using selective repeat, it means Only 3 has been received uncorrupted. It does not say anything about the other packets. Next হচ্ছে আবার there are a few with a flow diagrams. এটা detail এ যাচ্ছি না because once again selective repeat details you don't need to know, and if you want you can do this by yourself to help your understanding of flow diagrams. যেটা বলেছি exam will have one flow diagram problem, right, where I might give you, like part A and part B. Part A will be give you the text list of scenarios and have you draw the flow diagram. Part B would be give you a flow diagram and have you go from there to a list of participants. We can do this as an example. Okay. Next, Ashi. So, about once again, the previous slide we saw that the send window must be less than 2 to the power m. Everyone, right? We went through one slide. Remember, so that the scenarios where our old packet is sent, right, is resent, but it is interpreted to be a new packet so that this does not occur. Everyone. So today what I'm saying is for selective repeat, for go back and the requirement was your window size had to be less than 2 to the power m. For selective repeat, it has to be less than half of 2 to the power m. So even more constrained. Reason is previous case, go back and we allowed the receive window to be only of size 1. Here, because we allow the receive window to be of size more than 1, the 2 scenarios. Here, size has to be, here m is set to 2, so 2 to the m is 4, right? So half of that is 2. So in this case, the send windows of size 2, receive windows of size 2. In this case, window is more than 2, it's allowed to be 3. So in this case, we see if all packets are received correctly and all acts are lost, then packet 0 is retransmitted. But the receive, I'm going through this quickly, I'll tell you why. Receive window has advanced to allow the acceptance of the new 0, but it assumes the old 0 resent to be the new 0. And if window is allowed to be 2, here 0 is sent, receive window allows only 2 and 3, not packet 0. The 0 resent is discarded. So this one I'm not going through in detail because selective repeat you don't need to know, but just to connect with the previous case. And if you are interested, you can go through it yourself. Right? So here all the packets are received, all the acknowledgements are lost. This is the extreme case. So the receive window so because packets are received, receive window slides forward. Because acknowledgements are not received correctly at the sender, send window does not slide. So then in the extreme case, this scenario might occur where the two expect 2 different things. So 0, meaning of packet number 0 end up being 2 different things to the 2 ends. Because the 2 ends cannot see each other. Here, the constraint is even more. That's it. Just last slide is saying, often in bidirectional channels, in full duplex channels, you may not have separate acknowledgement packets. You might piggyback the acknowledgement on a data packet itself. So this is also to save bandwidth. To make the system entitled to save bandwidth, each packet might have a sequence number, which is the data, right? Sequence number of the data packet. And also you might have an acknowledgement number, which means you're acknowledging a data received in the reverse direction. So you might add an acknowledgement number field to the data field. You should have seen piggybacking algorithms in the computer architecture class. You're trying to save control packets, basically. Just the idea of it. Obviously, today's lecture is not in the final. That's it. Okay. Lecture 6, I will take a picture now. The TA to upload it by today, by the lab class. Yes.
স্যার এখান থেকে ভাইভা থাকবে?
না, থাকবে না, এখান থেকে কিছু থাকবে না। এটা জাস্ট আমি করলাম বিকজ এই যে মানে doing some more flow diagrams will give you practice, right? Doing some more এই যে window, send window, receive window diagrams will give you practice. That's why I will not ask you about selective repeat. I will only ask you up to go back in.
স্যার
Yes.
স্যার আমাদের যে মিডের সিলেবাস ছিল ওইটা কি মানে আমাদের থিওরি যে রিটেন পার্টটা এক্সাম হবে ওইটাতে ইনক্লুডেড নাকি শুধু ভাইবার জন্য?
সব included. Direct question ও থাকবে। Right? Direct question ও থাকবে from every chapter. I might have 4 questions, one from each chapter. Or maybe, like 5 questions, 2 from chapter 18, 1 from chapter 23, and 1 each from the previous chapters. Process will be the same, 1 or 2 definition question and the rest maths. And I will probably make a 1.5 hour exam and give you 1 hour time, or make up a 2 hour exam and give you 1 hour time. See how many you can do, right? And then scale it by the highest again. Last time I scaled it by the second highest. Okay. Subjectটার উপর don't spend too much time, but আবার বলছি what is important is to understand flow diagrams, guys. Because this actually tests your understanding of the protocol. And that is what I expect you to remember 6 months after the course, right? I mean, given a flow diagram, be able to analyze it. It's like you have done flow charts in your basic programming classes. Okay? You will never forget them. Algorithm details, no one remembers. And only people who exactly code, implement these remember details. Okay.
Sir,
Yes, please.
the Viber formatটা like আমাদের যখন আপনি কোশ্চেন জিজ্ঞেস করবেন will we answer by conceptually or something like that, or we have to be straight to the point, accurate?
ভাইবা তো করেছো তুমি আমার সাথে, তো জানো তো, তাই না? Depends on the, তো বলা যায়, depends on the question, right? My job is to test or understand if you have understood.
Yes, sir.
Right? So your job is to convince me that you have understood.
I was talking about the last question, sir. Like যেটা আপনি বলেছেন, you'll take it as a job interview.
Oh, that's a special ভাইবা। না, it depends on the question. It will be doing a live question. That's it. It will sort of be like doing an exam question, except you will do it live.
Okay, sir.
That's the difference.
Okay, sir. Got it.
Okay, it's very easy, right? I might pick a slide. That's what I'm saying, right? A different slide for each of you from one of the lectures and tell you to explain that to me.
Yes, sir.
So if you have understood, you will be able to explain to me.
Yes, sir.
এটাই তোমার কথায় আমি এটা বুঝতে পারবো তুমি বুঝেছো নাকি বুঝো নাই, তাই না? obviously if you just read out the text, that is obvious to me you have not understood. Right? If you explain in your own words somehow vaguely, I will understand that okay, you have understood. Right?
জি, বুঝতে পেরেছি, স্যার।
Anything else?
আমাদের এক্সামটা কতক্ষণে হবে?
12টায় লগ ইন করবা, 12:30টার মধ্যে।
টোটাল টাইম কতক্ষণ থাকবে এক্সাম টাইম?
চিন্তা করিনি, between 1 to 1.5 hours. 1 hour smallest, 1.5 hour maximum.
Okay, sir.
Right? I will, once I make up the question tomorrow, I will know.
Okay, sir.
Because a lot of people have exams at 2 o'clock, right? And I will have to give you time to upload it as well. So maybe 1 hour, 15 minutes. Right?
Yes, sir.
Right? And this time for uploading, you will have 5 minutes and you have to stick to that, right? Last time there were penalties. Some of the penalties I excused, right? So have a backup net connection, right? 2 SIMs. And some people also suggested taking the exam during the day so that if you have, electricity problems, it's less likely during the day, right? If you're in remote part of the country. Right? Some people are in the villages. So if you're in the remote part of the country, load shedding is less likely during the day. Okay. Extreme scenarios are different, right? Extreme scenarios, I will, once again, I will excuse, but, right? But, general scenarios, right? Because we have done it once. Make sure your mobile does not hang, or make sure you have a spare phone next to you. And if I give you 5 minutes is sufficient time now that you have done it once. You'll have to take pictures, convert to a PDF, right? Go into one PDF, save it as your ID number, and then upload. Right? Please practice or look at how we did it in the meter. Even I have forgotten. And I will have to look it up again. Yeah.
স্যার বোনাস ল্যাবটা কি আজকে করাবে?
বোনাস ল্যাবটা হচ্ছে কোয়েশ্চেন পেপারটা তোমাকে দিয়ে দিবে, ইউ ক্যান ডু ইট ইন ইওর ওন টাইম এন্ড সাবমিট ইট টু হিম।
আমাদের অ্যাকচুয়ালি মানে অ্যাসাইনমেন্ট 3 and 4 এর মার্কসটা কি দেওয়া হয় না স্যার, তাহলে একটু স্যার দিলে
আচ্ছা জিজ্ঞেস করো, ওকে জিজ্ঞেস করো, দুটোর সময় আমিও থাকবো, লেটস আস্ক হিম। ওকে ওকে, কুইকলি লাঞ্চ করে ফেলি, আজকে লাস্ট ডে তো আরামে। হ্যাঁ, আবার 2টার সময় দেখা হবে। বাই বাই।